This is the Math 2 lesson summary video for the lesson entitled Parallelism Preserved and Protected. In Lesson 8, Parallelism Preserved and Protected, we took a look at our rigid transformations, which include translations, rotations, and reflections. The purpose of this lesson was to establish some parallel postulates for transformational geometry. And if you recall from an earlier lesson, we did discuss what the word postulate meant, and so you will want to add these two vocabulary words to your notebook. A postulate is a statement that we accept in geometry to be true without proof, and a theorem is a statement in geometry that is supported by justification and proof. In this investigation, we explored using coordinate grids as well as geometry software, translations, rotations, and reflections, and how they align with parallelism. In the first part of this investigation, we were asked under what conditions are corresponding line segments in an image and its pre-image parallel after a translation, and we were then told which word would best complete this statement. So we experimented with triangle ABC, in this case in the coordinate plane, and we translated triangle ABC, right 3 units and up 4 units. Once we translated our triangle ABC, we could see that line segment AB was parallel to line segment A prime B prime. Line segment AC was parallel to line segment A prime C prime, and line segment BC was parallel to line segment B prime C prime. We know that line segment AB is parallel to line segment A prime B prime because the slope of line AB is equal to 5/3 and the slope of line segment A prime B prime is equal to 5/3. If you recall from Math 1, the slopes of parallel lines are always congruent. Therefore, we concluded, and we put this in our notes, that the parallel postulate for translations, after a translation, corresponding line segments in an image and its pre-image are always parallel or lie along the same line. We then took rotations, and we were asked to explore if we took a figure, and in this case we put triangle ABC in the coordinate plane and we rotated 180 degrees. So I'm going back to unit 1 on transformations, and I rotated triangle ABC to get my triangle A prime, B prime, and C prime. And what I noticed and observed visually was that line segment AB in this case was parallel to line segment A prime, B prime. Line segment BC was parallel to line segment B prime, C prime. And finally, line segment AC was parallel to line segment A prime, C prime. So we added this to our notes, the parallel postulate for rotations. Keep in mind, because this is a postulate, we are accepting it to be true without proof. After a rotation of 180 degrees, corresponding line segments in an image and its pre-image are parallel, or they can lie on the same line. The final thing we were asked to investigate was the fact that if we reflect over a line, an image, what will happen from our pre-image points to our image points. So what we notice is that actually when we reflect over a line, in this case I drew my line of reflection to be the line x equals 0. And if you recall from unit 1, you can count to that line of reflection and count over. We notice that not all of the line segments will be parallel. The ones that will be parallel will be ones that will be parallel to the line of reflection. So for example, I can see here that line segment BC is parallel to line segment B prime C prime, and that is because it is parallel to the line of reflection. In addition, line segment AD is also parallel to its image, line segment A prime D prime, because it's also parallel to the line of reflection. If you notice that line segment AB will not be parallel to line segment A prime, B prime, but it will lie on the same line. If you need more help on the Ready, Set, Go homework for this task, please remember to check the Canvas Student Support site.